Alright, good evening, Damodaran. I guess more people will join sooner. We will start now. Um, Thanks for joining. And yeah, so I welcome you all to the week 5 problem solving sessions of the course Numerical Methods. And this week we continued our discussions on interpolation methods. And I think we completed interpolation and we started numerical differentiation. In this week, what we saw is central difference interpolation formulas and Lagrange interpolation formula, divided difference interpolation, and Hermite's interpolation. So these are the main thing. We also saw numerical differentiation, but we will cover that in the next week. So it's not fully completed, so it will continue in the next week. So we will cover that in the next week. Today we are going to cover these. We are going to solve some problems for these interpolation topics. So let me just quickly go through what happened in the class. So now we last week we stopped at forward difference and backward difference and extrapolation. I mean Newton's forward and backward difference and extrapolation. And so we will begin from there. So this week we saw like central difference table, where there are like two methods. One is Gauss backward and Gauss forward, each applicable for different variations of p. We know what is p, x minus x naught by h, and all these interpolation scheme is for equidistant data points. So here if your p lies in between these and also your interpolation value is in the center of the table, then you go for Gauss backward central difference. If not, if it lies like this, then you go for Gauss forward central difference. And then there are two more, Stirling's formula and also Bessel's interpolation formula. These are a little bit advanced interpolation methodologies. And then we saw like each method's formulas. So I'm just providing you the final formula here. And this one is permutation. I think I didn't write that here, but you can check the class notes for that. So this is for central difference, where you have so basically you start from minus half and then you go like this. So in the forward difference you will have y plus half, so that's the major difference. Otherwise both are almost same. So just these coefficients you need to take care permutations correctly, that's it. And then you have Stirling central difference formula. Additionally, what you have is you have this mu operator, average operator. So here you may need to do half of e minus half plus e plus half. So this part you need to replace in terms of mu. And then we saw exhaustive proof of how this is derived and how we are getting this. So coefficients are like it comes it follows this formula. And then similarly there's also Bessel central difference formula. Okay, so but all these formulas are for equidistant data points. Now we have if we have data points that are not equally spaced, if the spacing keeps on changing but does not follow any order, if it is random, then how would we do it? How do we interpolate between the data points? So that for that you have Lagrange interpolation formula, and also you have Newton's divided difference formula. In Lagrange interpolation formula, what you have is you have this Lagrange coefficients, and Lagrange coefficients is can express something like this. And this Lagrange coefficient has this special property of Kronecker delta. So this delta ij is called Kronecker delta, where if I and j are equal, then the value is 1. If it is not equal, then it becomes 0. So basically you just substitute this, let's say you are trying for xi, you substitute this I here. Everywhere if you substitute, then numerator and denominator become same, so you cancel them out, so you will get 1. If you substitute j, something else, let's say instead of x, so here it is written for if I put x to be x naught, then one of the term becomes 0. In that way the entire polynomial becomes 0. Okay, so whatever, so if any data point, if you substitute in the Lagrange coefficient, then that term will become 0. So that's the special property that you have, and using this you can construct a polynomial. It's a basic simple polynomial, L naught of x f of x naught plus L1 of x f of x1 plus you continue with till L of n f of xn. So if you have n data points, your Lagrange interpolation polynomial is going to have n terms. That's the thing. And then we have Newton's divided difference interpolation formula. So for that we need to know what is divided difference. It's basically the difference between function divided by the spacing, which is x1 minus f of x1 minus x0 divided by x1 minus x0. If we want to include 3 data points, then you should take the last 2 data points minus first 2 data points divided by the entire difference. So that is what this. So you can continue this and you can write it for the n data points, and for the for n data points you can write the expression to be something like this, and based on this you can write the f of x to be f of x naught. This is your interpolating polynomial, or in this case it's an interpolating formula. You use this formula and then you put x equal to xp, you will end up getting f of xp. That's it. And this can be expressed something like this, and you can also find the error something like this. Okay, uh, and then finally we also saw Hermite's interpolation formula. Hermite's interpolation formula, the additional thing is it also requires derivative in those data points. So let's say you have 4 data points, and for x and y data points, if you also know the derivative in those 4 points, then your interpolating polynomial can have higher degree of higher degree basically. So you can have 2n plus 1 as your polynomial degree. So that's the special feature of this Hermite polynomial. So basically you will also use the derivatives available in those data points to construct your interpolating polynomial in such a way that gives minimum error. So that's why your error is also, if you calculate the error for that, then it will be 11. All right, so that's what we saw, and then we also saw numerical differentiation, and I think this week's for like this week's assignment does not require you to study numerical differentiation, so I am going to skip it. Maybe we will discuss that in week 6. Okay, uh, with the other methodologies together. Okay, any questions? So if you have any questions, you can ask me anytime. So today I have like 4 problems to solve. One each on one is on Stirling interpolation formula, the other one is Lagrange interpolation formula, and then the other 2 are Newton's divided difference formula. So Hermite I do not have today, but I think you guys can manage that. All right, any questions still now? I don't think there's any questions. So if there are no questions, then I will start with problem 1. The Am I audible? Let me check my recording. Okay. So the problem 1 is we have like 5 data points here. X and f of x is given. So we were asked to find f of x at x is equal to 0.2 using Stirling's interpolation formula. Okay. So we know maybe we can write down the interpolation formula first. So what is the interpolation formula? Stirling central difference. So this is your polynomial, which is yp equal to y naught plus p mu delta y naught plus p square by 2 factorial delta square y naught plus p plus 1 3. This is a permutation operation. We will see what this means. Del cube y naught plus p square into p square minus 1 square divided by 4 factorial del power 4 y naught, and you can keep on writing like this. If you want to express it in general terms, you can write it in this manner, and a where a are this big formulas. Okay, so here I'm just going to write it explicitly so that it's easy to understand. So for this, what we need to know is we need to find the differences. So let's construct the forward difference table. So x, y, it's minus 2, minus 1, 0, 1, 2, and y is 0 0.2397, 0 0.2809, 2806, sorry, 0 0.3179, 0 0.3521, 0 0.3837. Okay, so these are x and y. Let's write down the forward differences. Delta y is this minus this, which is going to be 0 0.2806 minus 0 0.2397. 0 0.0409. This is going to be 0 0.3179 minus 0 0.2806, 0 0.0373. How much is the other one? 23521, 3179, 0 0.00342, 0 0.3837 and 0 0.3521, 0 0.0316. I guess these are right. And del square y is going to be, first one will be negative, minus 0 0.0036, and second one is also going to be negative. It's going to be 0 0.0031. This is going to be 0 0.0026. Okay, and then del q, this is positive, 0 0.0005, and this is also positive, 0 0.0005, and then the fourth difference is going to be 0. Okay, so yeah, so now we have constructed the forward difference table. What we need to find out is f of x at x equal to 0.2. So where does this lies? It lies somewhere here. 0.2, x equal to 0.2 is somewhere here. So what we are going to do is we are going to take this as x naught. Okay, so which means xp is 0.2 and x naught is 0, and h is the distance between the x data points, so it's going to be 1. So if that is the case, p is going to be xp minus x naught by h, which is 0.2. Okay, And whether this is so, we chose x naught because p will be 0.2, because I think let's say if we go back to the nodes, you can see for Stirling's formula p should be between 0.25 to 0.25. So in that case only this, if you take x naught to be 0, then that only satisfies this condition, minus 0.25 p less than 0.25. So that's why xp is, or x naught is 0. All right, so we know p. Now you can start substituting here. We need to know what is this p plus 1. This is a permutation. So let's go back to the slides. So you have here p plus 1. Is there a permutation? So in general you can write this as p plus m by p plus m into 2m, can be written something like this. So that is what we are going to write here. So we know that p plus m into m is going to be p plus m, p plus m minus 1. You continue with p plus 1, p minus 1, continue with p minus m plus 1 divided by 2m. Okay. Here what do you have? We may need to take is this the right one? So for example, if you take m equal to 1, it's going to be p by 2, and if you take m equal to 2, it's going to be p plus 1, p plus 1 by 3. Okay, so now in that way, if you write the p plus 1 by 3, it's going to be p plus 1, p minus 1 divided by 3 factorial, which is going to be p into p square minus 1 by 3. 3 factorial is 6. Okay, and then other things we already know, so let's write this down. I can just copy paste this. Only thing is, this part we are going to write it as p into p square minus 1 divided by 6. Let me check whether this is right. P into, okay, this one, p into p square minus 1 by 6. Okay. Now we also, okay, we'll come to this. So now since you chose this as x naught, this is going to be your y naught. Okay, and now you have this delta y naught, mu times delta y naught, delta square y naught, and mu times delta cube y naught. Okay, delta power 4 y naught is 0 because the fourth difference is 0 here, so we can ignore this term. We can ignore this. Only thing is there is this mu. Mu is an average operator, which is e minus half and e plus half divided by 2. So if you go back, since we studied long back, yeah, here. So it's mu times f of x is f of x plus half and f of x minus half divided by 2. Okay, so in this case it is going to be um, since this is y naught, it is going to be, this is minus half and this is plus half. Okay, so this is going to be average of these two. Let me mark this down here. So let's write this down. Y naught is 0.3179 plus p is 0.2 into mu is average of 0.0373 plus 0.0342. Okay, that's it. And then you have p into p square minus 1, which is 0.2 into 0.2 square minus 1 divided by 6 into, oh okay, sorry, we missed the term. So now this term, which is 0.2 square by 2 factorial, which is 2, into delta square y naught, that is going to be simply this one. Okay, which is minus 0.0031 plus 0.2 into 0.2 square minus 1 divided by 6 into, again you have a average operator. So what you have to do, you have to average two of them above, which is 0.05 and 0.08. So this average is going to be simply 0.005, but for the sake of completeness I will write them 0.5 plus 0.0005. Okay, that's it. So now you simplify this expression, you are going to get the results. So this is going to be 0.3179 plus 0.0373 plus 0.0342 divided by 2 into 0.2, which is 0.00715 0.2 square divided by 2 into 0.0031, which is minus 0.0000662 plus 0.005 divided by 0.2 into 0.2 square minus 1 . This is also negative 4016. Okay, how much is this? 0.3179 plus 0.0000715 minus 0.4062 minus 0.4016. This is something like 0.3249. Okay, so if you were to here it only 016 5016. So this will be your final answer, 0.3249. So for example, you can go and check. Here you have 0.32, 0.28, 0.3179. So it is in increasing order. So we expect at x is equal to 0.2 to be a little higher than 3179, and which is what you see here, 0.3249. Okay. Okay, is that clear? So this is how you can do Stirling's interpolation formula. If you want to do the same thing with Bessel's, for Bessel, I think what is the p value? Let me check. For Bessel, the p value is 0.25 to 0.75. So you may need to choose a different, x naught. Probably you may need to choose, I guess, x naught to be 1. Then you will end up having this interval. For Bessel, it's 0.25 p 0.75. All right. I hope this is clear. If there are no doubts, then we can move forward to the second problem. So in the second problem, what we are asked to find out is the following tabular data is given. Using that, find the Lagrange interpolation formula, and using the Lagrange interpolation formula, find f of 4. So basically we were asked to interpolate to find the value at 4. Okay, find the value of f of x at 4. But we should use Lagrange interpolation formula. Let's write down the Lagrange formula. And here you can note that it from 2 to 3 the difference is 1, right? So here the difference is 1, here the difference is 2, here it is 3, and here it is 4. Although this follows a trend here, it not necessarily need to follow that, but if it is not equally distant, like these points are, if it is not equally distant, then you cannot use the central difference or Newton's forward or backward difference formulas. Okay, you need to use either Lagrange interpolation formula or divided difference. Okay, now let's write down the polynomial. So we can write this as f of x, or the Lagrange polynomial is actually L naught of x, f of x naught plus L1 of x, f of x1 plus L2 of x, f of x3, plus you can keep on writing like this till Ln. Here you have n to be 5, right? Or if you start from 0 x naught, you will have 4. So ideally you will write it for 5 data points, which will be, sorry, this is 2, this is 3, we will write it for L4, x of 4, because we have 5 data points. Okay, and let me write down the L also. Li of x is nothing but x minus x x naught, x minus xi, x minus x1, and you continue it like this till x minus xi minus 1. You do not write for x minus xi, instead you jump that one, xi plus 1, and then again you continue till x minus xn. The same thing but here you replace it with xi's. That's it. Xi minus x naught, xi minus x1. You continue with till xi minus xi minus 1, and then you jump that point xi minus xi plus 1. You continue it, and then finally you write xi minus xn. So this is your Lagrange coefficients. So for that, for this problem we can write for L naught. So what is it for L naught? L naught is going to be, since you have like 5 data points, you will have you know 4 terms in the numerator and denominator, which is going to be for L x naught is going to be x minus x1, x minus x naught will not be there, x minus x2, x minus x3, x minus x4, okay, divided by x naught minus x1, x naught minus x2, x naught minus x3, x naught minus x4. Okay, this is your L naught. Similarly, you can write L1. Should I write everything? Okay, let me just write it for once. X minus x naught, x minus x1, x minus x, sorry, x minus x1 will not be there. So x minus x2, x minus x3, x minus x4, and the same thing with x1 in the denominator. x1 minus x2, x1 minus x3, x1 minus x4. Okay, and the L2 will do something here. X naught, x minus x1, x minus x2 will not be there. x3 minus x4 divided by x1, x2 minus x naught, x2 minus x1, x2 minus x3, x2 minus x4. Okay, then L3 x minus x2, x minus x3 minus x naught, x3 minus x1, x3 minus x2, x3 minus x4, and finally L4 is going to be x minus x naught, x minus x1, x minus x2, x minus x3, x4 minus x naught, x4 minus x1, x4 minus x2, and x4 minus x3. Okay, so for each and every data point you need to write this coefficient, and then you can substitute that in this polynomial. So if I want to write this, let me just write this as f of x. Then this is going to be L naught times f of x naught plus f of x1 plus f of x2 plus f of x3 plus f of x4. So this is your entire Lagrange polynomial. Now what do we need is we need to find now the x is going to be so let me write down x naught. X naught is 2. So you here you no need to worry about what should be the order. You can just directly take based on the table in that order. X1 is 3, x2 is 5, x3 is 8, and x4 is 12. Similarly, corresponding f of x's you can take. Okay, now only thing we don't know is x, for which we are trying to find out. Here the x is going to be, we want to find f of 4, so we are going to take x to be 4. Okay, so x is 4. So then if I want to substitute here, it's going to be f of 4, and then you can do the same thing over everywhere here. So let me not disturb this. Let me just go to a new page. Let me write f of 4 is equal to, so if you substitute 4 here, what happens? This is 4, this is 2, 4 minus 2, 4 minus 3, 4 minus 5, 4 minus 8. Okay, correct? 4 minus 2, 4 minus 3, 5, 8, 3. Wait a minute. No, it should be, sorry. This is 4, this is x1, right? So it should start from 3. This is 3, this is 3, this is 5, this is 8, and this is 12. Okay, so it is 4 minus 3, 4 minus 5, 4 minus 8, 4 minus 12, divided by 2 minus 3, 2 minus 5, 2 minus 8, 2 minus 12, times f of x naught, which is 10, times 10. Okay, this one, 10 f of x naught. This is the first term. The second term is going to be 4 minus 2, 4 minus 5, 4 minus 8, 4 minus 12, divided by 3 minus 2, 3 minus 5, 3 minus 8, 3 minus 12, multiplied by 15, plus the third term is 4 minus 4 minus 2, 4 minus 3, 4 minus 8, 4 minus 12, divided by 5, right? 5 minus 2, 5 minus 3, 5 minus 8, 5 minus 12. This would be very easy if you just program this to 25 plus, and it would also be a good exercise if you guys are if you want to do some programming, then please try to implement this in a program. Now this is going to be 4 minus 2, 4 minus 3, 4 minus 5, 4 minus 12, divided by 8 minus 2, 8 minus 3, 8 minus 5, 8 minus 12, multiplied by 10, 15, 25, 40, and 60. Okay, this is going to be 40 plus 4 minus 2, 4 minus 3, 4 minus 8, 4 minus 5, 4 minus 8, divided by 12 minus 2, 12 minus 3, 12 minus 5, and 12 minus 8, multiplied by 60. Okay, now you just need to do this calculation. How much the first term is going to be? 4 minus 3 is 1, 4 minus 5 is minus 1, 4 minus 8 is minus 4, and 4 minus 12 is minus 8, minus 32, divided by 2 minus 3 is minus 1, 2 minus 5 is minus 2, and 2 minus 8 is minus 6, and this is minus 10. So first term is into 10 minus 2.667, and let me take 4 decimals. Okay, the second term is going to be 4 minus 2 is 2, 4 minus 5 is minus 1, minus 8 is minus 4, minus 8 divided by 1 minus 2 minus 5 minus 9. So if you guys get the answer before me, please let me know. This comes out to be 10.6667. okay, this is 1 1, no, not 1, 2 1 minus 4 minus 6 divided by 5 minus 2 is 2, 3 2 minus 3 minus 7 to 25, 9.5238. Yeah, hopefully these are right. 2 into 1 into minus 1 into minus 8. Divided by 6, 5, 3 minus 4 into 40 minus 1.7778, and then you have 2 1 minus 1 minus 4, 12 minus 2 is 10, 12 minus 3 is 9, 12 minus 5 is 7, 12 minus 8 is 4. Into 60 plus 0.1905. Okay, moment of truth. Minus 2.667 plus 10.6667, 9.5238 is 1.778, 0.1905. Okay, so certainly there is some mistake. So this has to be 20. Okay, there might be some mistake in this. I will let you guys figure this out. Okay, the answer is 20. It cannot be. I am getting something like 16, so I might have miscalculated one of them. I'm getting something like 16, but 16 is not the answer. 20 is the right answer. Okay, you guys can I will leave it to you as an exercise. Figure this out. Okay, but anyway, what I wanted to show is how we should proceed to get the solution. Okay, you just need to write down all the L naughts, I mean coefficients, Lagrange coefficients, and then put them in the formula. That's all. Okay, any questions? Or did you guys, any of you, arrive at the correct solution? 20. 10, 15, 25, 40, 60. 10, 20, 15, 25. Okay, 40 instead of 40. 10, 15, 25, 40, 60. Okay, correct. All right. We will, if I have time in the end, I will figure that out. If not, you guys find the problem. If there are no more questions, then we will move forward to the third problem that we have here. So the third one is determine the interpolating polynomial. So here we are asked to find the polynomial instead of doing an interpolation using Newton's divided difference formula for the following data set. So we should use Newton divided difference because it is not equally spaced. You can see from here. Here there is a 2, here there is a 3, here there is a 1, here there is a 3. So it's random. Okay. So here we are going to use Newton's divided difference formula. And what is that? Newton's divided difference formula. So this is your divided difference formula. So I'm just going to copy this to save time. Okay, it's very small. Okay, so this is your Newton's divided difference formula. So for this, since you want to find out the polynomial, you just keep the x as such. You do not substitute any value for it, but you know the x0, x1, x2, x3 and x4. So based on that, you find these divided differences, and then finally you substitute them in this relation. Okay, so that's it. So let's try to solve this. So first thing what we need to know is we need to construct a table. So let me move this up a little bit. So we have x, we have f of x, and x varies from -4, -1, 0, 2 and 5. And this varies as 1, 2, 4, 5, 33, 5, 9, 1, 3, 3, 5. I hope these are not in your, there's a high chance that it will be same, but okay. All right. So this is not in your assignment, so I'm free to do this. So now, first we need to find the first differences, divided difference. We are going to just write it as first dt. And how do we do it? So this is your x0, right? This is x0, x1, x2, x3 and x4. So the first divided difference is going to be x1 minus x0 divided by x1 minus, sorry, f of x1 minus f of x0 divided by x1 minus x0. Okay, and you put that here, and then you similarly you do it for every other thing. You fill this table, and the second difference you can use these values to do the second, third and fourth. Okay, and that way this table is very helpful. So let's try to do this. So x1 is 33, f of x1 is 33, 1, 2, 4, 5 divided by -1 minus of -4 is 3. So this is -404. Okay, and this is going to be 5 minus 33 divided by 1, so -28. So this is minus. So I was thinking maybe we can write it in the middle for better clarity. And 9 minus 5 divided by 2 is 2. This is 2. And 1335 minus 9 divided by 3. This is 442. Okay. This is first divided difference. And then now the second divided difference. This is going to be this minus this divided by this minus this. Okay. I think in that way it is better if I just write it how should I do this? Okay, I will continue with this. So minus 28 plus 404 divided by 4, which is 94. Okay, and for this you need to 2 minus of minus 28 divided by 2 and minus 1. Okay, so please understand this. So 2 minus of minus 28 is 2 plus 28 divided by 2 plus 1, which is 3. So this will be 10, and the final one will be 442 minus 2, 440 divided by 5, 88. Okay, now the third difference is going to be this minus this divided by this minus this. Okay, so you can see how it is going. Okay, so 10 minus 94 divided by 2 plus 4, which is 6, minus 40. And then 88 minus 10 divided by which one? 5 and minus 1. 5 minus 4 minus 1 is 6, so it's going to be divided by 6, which is 13. Okay, similarly you can also do fourth difference, which is going to be 13 minus 14 divided by 5 minus 4, which is 9. 5 minus of minus 4, which is 9. This is 3. Okay, that's it. Now let's write down the formula. So f of x is going to be f of x naught plus so here f of x naught is 1245, so we can take that 1 2 sorry I'm just going to directly write down the value 1245 plus x minus x naught is minus 4, which so it becomes plus 4 into f of x naught x1, which is this value. Okay, so f of x naught x1 is this value, right, which is minus 404 plus x minus x naught x minus x1. So x minus x naught is x plus 4 and x minus x1 is minus 1, so it's x plus 1 into f of x naught x1 x2, which is this one. So maybe I will mark that now. This is x naught, this is x, these two. So these are the values we used, f of x naught. this value, and then this value, which is f of x0, x1, x2. So this is going to be 94 plus x plus 4, x plus 1, x minus x2, which is 0. So let me x minus 0, and then the third difference is going to be this one, minus 40. Okay, this is minus 40 plus the final one is going to be 3. So for this you will use all the data points: x plus 4, x plus 1, x minus 0, x minus 2 into 3. Okay, and there is no fifth divided difference, so we cannot use that fifth data point here. All right, so now we need to simplify this. Let's try to simplify this. 1 2 4 5 plus I'm not going to simplify a lot. 404 into x plus 4 plus 94 into x plus 4 into x plus 1, and then minus 14x into x plus 4 into x plus 1, then plus 3x into x plus 4, x plus 1, and x minus 2. Okay, you can simplify this further. Then you will get I think you will get fourth order polynomial. You have 4x multiplication here, so you will get x power 4 polynomial. So y of x is going to be, so I have the solution here. I will write it down for you guys. So it is something like 5 minus 14x. I will let you guys do the math. 6x square minus 5x cube plus 3x power 4. So when I did this, this is what I got, but please confirm. Okay, but ultimately the aim is you have to do this forward difference table, sorry, the divided difference table. This is a divided difference, and you have to be careful while doing it. So because you need to know denominators, x0 minus x1, x0 minus x2. So in that way, to when you are doing this, this will be your this is the difference that you need to take. When you are doing this, these two difference you need to take. When you are doing this, these two difference you need to take. And when you are doing this, the entire difference you need to take. Okay, so that is how you construct this entire table. And you need to construct, although we are not using any of this value, you need to construct this, then only you will end up having the fourth difference. So you need to find out this entire table. So once you write this table, you just use the formula that we have here, substitute them, you will end up having the polynomial. Okay, any questions? All right, I guess there are no questions. There are no questions. Let's just quickly solve the another problem. This is also again the Newton's divided difference interpolation. Only thing is we are asked to find a missing term. In the previous case, if you see last week also we saw one problem in this manner, like we were asked to find the missing function value for one of the data point. There we use something like, because it was an equidistance, there we used forward difference. And in fact what we did is we fitted a third order polynomial or fourth order polynomial based on how many data points we had, and then from there we directly got the function value, right? So if you can go back to previous week's problems that we solved. Here we cannot do that because our intervals are changing unevenly. If you look at it, here it is changing 1, here it is changing 2, here it's again 1 1. So um, you could actually fit a third order polynomial, fourth order polynomial here, but since they have asked to use Newton's divided difference interpolation, we should follow what they have asked. Okay, so we are going to again construct the same table. Now what we are going to do is, since we don't know the value here, we will remove this data point. If we remove, we have only 4 data points. Using these 4 data points, you construct a Newton divided difference polynomial, and for the 5th data point, which is for x is equal to 5, you try to using that polynomial, you try to find the uh, function value. So that is what we are going to do. So let me write down that table. It's going to be 1 2 4 and 5 we are going to skip because we don't know the value. Okay, 14 15 5 and 9. Now the first divided difference is going to be 15 minus 14 divided by 2 minus 1. This is going to be 5 minus 15 divided by 4 minus 2, and this is going to be 9 minus 5 divided by 6 minus 4. Okay, how much is this? This is 1 by 1, so I guess this is just 1. This is minus 10 by 2, so I'm going to write minus 5 here. Okay, and this is 4, and this is 2, so it's going to be simply 2. And then second divided difference is going to be minus 5 minus 1 divided by 4 and 1. This is going to be 2 minus 5 divided by 6 minus 2. This is minus 6 by minus 6 by 3, so this is going to be simply minus 3, sorry, minus 2. Minus 6 by 3, right? So minus 2. And this is minus 3 by minus 4. Okay, 2 minus of minus 5, so plus by 6 minus 2 is 4. This is 7 by 4. Okay, then third order difference is 7 by 4 minus 2 divided by 6 minus 1, it is 5. 4 2 8, 7 minus 8 is minus 1, minus 1 by 4, which is minus is it right? Oh, wait, 7 by 4 plus 2, right? 7 by 4 minus of minus 2, so 4 how much is this going to be? 4 2 8 8 7 is 8 and 7 is 15 by 4, and 15 by 4 divided by 5, which is multiplied by 1 by 5, 3, so it's 3 by 4. I don't know why I took this much time to do this. So this is your first, this is your difference table. Now we can just simply do f of x. F of x is f of x naught plus x minus x naught, f of x naught x1, correct? Is this correct? Yeah. Plus x minus x naught x minus x1, f of x naught x1 x2. How many we have? X naught x1 x2 x3. So we have one more term, x minus x naught x minus x1 x minus x2 x minus x3, f of x naught x1 x2 x3. Okay, and this is your x naught, so this is your f of x naught, and this is your f of x naught x1 x naught x1 x2 x naught x1 x2 x3. Okay, let me just substitute it, and this x is going to be now, what are we asked to find? X is 5, and what is y they are asking. So f of 5, or in another case y at x is equal to 5, or f of 5 is f of x naught, which is 14, plus x is 5, 5 minus x naught is 1, and f of x naught is x naught x1 is 1, plus 5 minus 1, 5 minus 2, into x naught x1 x2 is minus 2. Please let me know if I make any mistakes. Plus x minus 1, f minus 2, f 5 minus x2 is 4. I think this should not be there. So because you have till x naught x1, here you have additionally x naught minus x2. Yeah, I think I made a mistake here. So this has to be f of x naught x1 x2 x3. Okay, 5 minus 4, and then into minus 2 and 3 by 4. Okay, that's it. Now you can simplify this. 14 plus 4 plus 5 minus 2 is 4, 4 3 is 12, 12 minus 24, and then this is going to be again 4 3 is 12, 12 1, 12 into 3 by 4. So 3, this is going to be simply 9. Okay, this is going to be 28 minus 24 is 4, 4 plus 9 is 13. Okay, whatever I solved comes out to be 3. Let me check this one more time. So this is 5 minus 1 is 4, 5 minus 2 is 3, 12, 12 into minus 2 is minus 24, and this is 4. 14 4 is, okay, sorry, 14 4 is 18. 18 plus 9 is 27. 27 minus 24 is 3. Okay, so y of 5, y of 5 is equal to 3. So this value over here is actually 3. Okay, this is how you do Newton's divided difference interpolation. So here you should note one thing. So till now, we see, if we see an increasing trend, we expect it to increase. So here you see the same thing, 14, 15, 5, and then you see a decreasing trend from here to here. But after 3, there is an increase to 9. So which means between 5 and 6, there is something happening. So till now, it's a decreasing trend, and from here it is an increasing trend, which means between 5 and 6, either it has a 0, okay, or it can also have a local minima, which means the function can reach a minimum value of, let's say, it can reach 2 and then it can rise up. That is also can happen. So one way to find that out is you include this number here and you express the polynomial here, express the polynomial like this, and you will end up finding all the roots. Okay, you express the polynomial like this and you can find the roots, and if you find the roots, then it crosses between 5 and 6, you will know. Okay, all right. So sometimes what people can also ask is, they can say that y equal to 0, I need to find where y is becoming 0. So in those places also you can use this formula, and you can actually invert this. So you take this as x and you take this as y, and still the whole formula will work. And yeah, so and then you put this to be 0 and try to find what is x. That will tell you uh, so that's basically the root. If y is 0, that's basically the root. Okay, all right. Are there any questions? So what we did today is we solved 4 problems. One on Stirling interpolation formula, the others on one is on Lagrange interpolation, and then we solved Newton's divided difference, both for getting the polynomial and also to find an interpolation value. So in fact, getting polynomial you can also get using the Lagrange function. So here too, what you have is this is the polynomial here is simply this. So you find L naught in terms of x and then substitute them. That will be your polynomial. And in fact, you can use any interpolation formula in that way to find the polynomial. Okay. All right. I think this would help you in solving this week's assignment. If you have any questions, feel free to ask. And if you don't have any questions, then we will meet next week. Okay, thanks for joining. I think we have around around 8 people here. All right, thanks for joining. I will be here for another half an hour or so. So if you have any doubts, you can stay back. If not, we will meet next week. Thank you. I can still see four more people. Do you guys have any doubts? So because I'm not going to teach anything anyway, I'm just waiting here for if someone else joins, and if they have doubts, I can clear their doubts. That's why I'm waiting. So you guys, if you have doubts, let me know. If not, you can leave. I'm not going to teach anything. Okay? Feel free to leave. You no need to stay. By the way, thanks for joining. Yeah, I would please also join upcoming sessions too.